Hello, this is the second video of the first vector series for OCR AS Core Pure Further Mathematics. It covers multiplying vectors to form a scalar product. We already know how to add and subtract vectors, but what about multiplication? We can define more than one way of combining vectors to make a product. Now, the scalar product is the sum of the products of the corresponding vector elements. It's useful because it gives us a way of finding the angle between the vectors, and we use a dot symbol to indicate this operation. To find the scalar or dot product of two vectors in two dimensions, we would write this as A dot B equals elements a1, a2 dot b1, b2, and that would equal a1, b1 plus a2, b2. In this example here, we have vector A equals 4 minus 1 and vector B equals 1, 2. Therefore, A dot B we would write as 4 minus 1 dot 1, 2, and that would equal 4 times 1, and I'll put brackets round to make that clearer, plus minus 1 times 2. As usual, you need to be really careful with signs. And that would give us a scalar product, in other words, just one number, constant product, of an answer of 2. Note that in 3 dimensions, the process for finding the scalar product or dot product is exactly the same. So A dot B, here where you have vector A in 3 dimensions, A1, A2, A3, and vector B, B1, B2, B3, would give us the scalar product A1 times B1 plus A2, B2 plus A3, B3, which will again just give us a constant number. You'll note that the scalar product is commutative because the multiplication of numbers is commutative. Here is an example in 3D where we have that P is 2 minus 4, 3, and we're taking the dot product with Q, which is minus 2, 1, 3. So again, using brackets to make sure we get our signs correct, that would give us 2 times minus 2 plus minus 4 times 1 plus 3 times 3 minus 4, and then another minus 4 plus 9, which would give us a scalar product of 1. In the second example, vectors A and B are given in component form where we have 1i minus 2 in direction j plus 5k. So let's just write that in this form here. And the dot product is with B, where we have 3i, 0j, and minus 1k. That would give us, so 1 times 3 plus minus 2 times 0 plus 5 times minus 1, or 3 plus 0, I'll add that in just for completeness, minus 5, a scalar product of minus 2. There is an alternative definition of a scalar product. So vector A, scalar product with vector B, equals the magnitude of A times the magnitude of B times cos theta, where theta is the angle between the vectors. You may wish to pause the video now and check how to prove this using the cosine rule, either from looking at your textbook or online. This result is important because it can be used to find the angle between the two vectors. In the next video, we will be doing just that.